In this video, we are going to introduce the definition of absolute convergence of a series. Suppose that you have a series that takes on the following form. The sum from n equals 1 to infinity of a sub n. The starting point doesn't really matter. The important thing is that we get this. This series is called absolutely convergent, or converges absolutely, if the series sum from n equals 1 to infinity of the absolute value of a sub n converges. Now the appearance of this series, this would be the absolute value of a sub 1 plus the absolute value of a sub 2 plus the absolute value of a sub 3 and so forth and so on. The only time that absolute convergence differs from convergence is if you have a series that contains both positive values as well as negative values. So in the event that you have a series, if a series is convergent, but not absolutely convergent, there we go, we call it conditionally convergent. If a series is convergent, but not absolutely convergent, we refer to it as conditionally convergent. Now, outside of simply using the definition of absolutely convergent, there are a couple of tests that we can use that will take us directly to absolute convergence. You can apply the definition of absolute convergence, which we'll do in just a moment. We also have the ratio test and the root test. Those will be introduced in future videos. Now, if something is absolutely convergent, that automatically makes it convergent. So if you are able to show that something is absolutely convergent, it is no longer necessary to test it for convergence. So this would be considered a theorem. If a series is absolutely convergent, then it is convergent. So having the statement absolutely convergent is actually a more powerful statement than simply saying convergent. Now, for an example of the definitions that we've seen so far, I would like to consider the following series. This is the sum from n equals 1 to infinity of negative 1 raised to the n plus 1 power times 1 over n. In case you didn't recognize it, this is the alternating harmonic series. And in the previous section, we were able to show that this series converges using the alternating series test. So using the alternating series test, this thing converges. However, if I apply the definition of absolute convergence, test for absolute convergence, we would be taking the absolute value of every single one of these terms. Now, by take the absolute value of every one of these terms, it's essentially saying that if there was an alternator in here, this will destroy the alternator. What an absolute value does is it says if it's negative, make it positive, and if it's positive, leave it alone. So the idea behind absolute convergence is we're simply taking away the alternating part of the series. You'll recognize that applying the absolute convergence test to the alternating harmonic series gives us simply the harmonic series. Excuse me. And we know from multiple tests, like the p-series test, the integral test, that the harmonic series diverges. So in the event that you have a series that converges but doesn't converge absolutely, you can say the following. The alternating harmonic series, converges conditionally. Now, that leads us to essentially 3 different possibilities for what it could be. So test it for absolute convergence, test it for convergence. There are 3 different qualifiers that we can now use. If you test for absolute convergence and you get a yes, then you can conclude that your series is absolutely convergent. If you test for absolute convergence and you get a no, you'll have to test for convergence. If absolute convergence is no, but convergence is yes, then you have an example like the alternating harmonic series. This would be conditionally convergent. Whereas if you test for convergence and you get a no out of this, you don't need to test for absolute convergence. You can just say this will be divergent. So the pesky cases are going to be these guys right here in the middle because they are going to require 2 tests. You'll have to prove that it's not absolutely convergent, but that it is convergent. Examples of those in future videos.